Okay, so yesterday we talked about the fundamental principle of counting. We talked about the tree diagram. We talked about how that's a lot of work and that it's easier if we just multiplied each thing, right? So we did a bunch of examples, and then we started getting into some crazy stuff that's kind of hard to understand. We're almost done. Let's look at number 20. Taylor, why don't you read number 20?
There are 10 names in a hat. How many ways are there to draw 3 names for first, second, and third prizes from the hat, assuming each person can win only 1 prize?
Okay, that's all right. We started this one yesterday. Okay, so pretend there's 10 of y'all. Well, not pretend, but there's typically 10 people in this classroom, right? Let's say I have a bowl, and I put all your names in here. And I'm going to say, okay, guys, I'm going to draw names for 3 prizes. First, second, and third place. You're all sitting there, okay? If I draw one, how many choices do I have on my first draw?
10.
10, right? There's 10 names in there. My first draw, I can choose any one of 10 people, yes? I draw a name. Let's say it's Michaela. Put it aside. Now my second draw, Cecilia, how many people are now in there?
9.
9, that's right, because I already drew one. So how many choices are there for the second drawing?
9.
9. So I draw a name. Oh, look, it's Cecilia. So Aiden, how many names do I have left for the third place?
Third place. 6.
No. Michael?
8.
8. The first drawing had 10 people, right, Aiden? Take Michaela out. Second drawing had how many people? Aiden, wake up, buddy. If there's 10 people in the bowl,
Yeah.
so the first drawing, I have 10 choices, right?
Mm-hmm.
So I take one out.
Yeah.
For second place, how many choices do I have this time?
9.
Yes. Take it out. How many choices do I have for the third place?
8.
Does that, there you go.
Yeah.
Okay. Wake up, y'all. All right, so 8, and then I take one out, and that's my first, second, third. Okay, so in this case, that's kind of what's going on here. It says, how many ways are there to draw 3 names for first place, second place, and third place? So how many names or choices did I have for first place, Taylor?
10.
How many did I have for second place, Taylor?
9.
And third place?
8.
And so we multiply all these together. What do you get, Taylor?
1/3.
Cecilia's got it.
728.
No.
Can I see it?
Hold on. Gabby, you had your hand up. 720. You were close. Any questions about that? All right. Let's look at 22. Michaela, why don't you read that one?
There are 5 choices of sandwiches, 2 choices of chips, and 3 choices of drinks. There is a limit of 1 sandwich, 1 bag of chips, and 1 drink.
Okay. That is useless information right there. All you want to know is how many choices do you have? So how many choices of sandwiches do you have?
5,
How many choices of chips do you have?
2,
How many choices of drinks?
3,
And we multiply them all together.
30.
Yep. 30. Sometimes they're going to throw in other information to confuse you. Let's look at 24. Gabby, you want to read 24?
Draw 3
Okay, when it says drawn tickets are not replaced, it's kind of like when I was drawing names out of the bowl for y'all, first, second, third place. If the first one I drew, I was pretending to draw Michaela's name. Do I put Michaela's name back in there for a chance for her to win first, second, and third place? No.
Yeah.
You keep that name out. Well, that's what 24 is saying there at the end. Drawn tickets are not replaced, meaning once they're drawn, they're drawn. You don't get thrown back in. So, excuse me, I'm talking. Draw 3 tickets from among 100 for 3 different door prizes. So this is going to be similar to number 20. Door prizes. So I have a first, second, and third place. So Gabby, how many choices do I have for drawing the first one? 100. How many for second? And how many for third? And now we multiply. Anyone got it? Taylor?
97. 970,200.
Okay. 970,200. Hold on. I have to answer my partner. $26. I got 2 more to do. Ooh, 26 is good. Michael! Read it, please.
Choose 5 students.
How many students?
5.
How many?
5.
How many?
5.
Okay, choose 5 students. Go ahead.
4 roles in a class play from among 24 in one class.
Okay, so this time instead of choosing 3 and stuff, we're choosing how many?
5.
Okay, now this is a play. Can one student do multiple roles? Really?
Technically, he can.
They want to choose 5 students for the different roles.
No.
So, no. Okay. Let's see where. Okay, so we have first, how many students? How many different roles are we talking about?
5.
There you go. Second, third, fourth, fifth roles. Okay. So how many does he have to choose from for the first one, Michael?
24.
How many for the second?
23.
How many for the third?
22.
Fourth?
21.
And fifth?
20.
Okay. Now, to save on time, I'm going to go ahead and tell you. It's 5,100,480.
Oh, yeah. And they should just have an audition.
So, out of 24 students, that's how many random choices. Those are how many, that's the outcome. How many different choices, outcomes you could have for 5 roles, just with 24 students.
That's a big gap in RNG.
That's pretty huge. All right, last one, 28. Emily, read it, please.
There are 4 choices of meat, 8
choices of vegetables and 2 choices of dessert. How many different meals consisting of 1 meat, 1 vegetable, and 1 dessert could
Okay.
be ordered?
So we have meat, we have veggies, and we have dessert. How many choices of meat do you have? How many choices of veggies?
8.
How many choices of dessert?
2.
And we multiply this together, and we get 64.
Oh.
Any questions about this? Y'all have it down? All right. Y'all are going to do page 422 to 423. You're going to do numbers 1 through 29 odd. And you don't have to make trees. You can just do it the way we've been doing it. This is due Monday. IXL, due Monday. Circle, graph, and what was the other one? Box and whisker? Whoops, box and whisker. Smart score of 50. And you have a quiz Monday.
It told me when I wrote box and whisker.